Solving equations, part B. So in part A, we did the first page of the solving equations note sheet, and now we're going to do the second page. Here are some examples of equations with fractions. They have the same rules. Doing inverse operations, we're just going to do some examples with fractions. So in this problem, like all equations, we want to isolate the variable by itself. So we'll leave it here on the right side, and we're going to, 19.6 is added to this side, so we're going to subtract 19.6 from both sides. And I'm going to rewrite this horizontally. I'm going to leave a little space here because I'm going to need to add those fractions. And now this side equals x. So 19.6, we got that away from the right side, x is by itself, and now we have to do 20/3 minus 19/6. We have to, because it is a fraction, we have to switch into a different color here. We're going to have to get like terms, and not like terms, sorry, a common denominator in order to subtract. So the lowest common denominator between 3 and 6 is actually 6. So this one is good. It's already over 6. This one we need to make it 6. So to get 3 to be 6, we have to multiply by 2. And we know the rule is for fractions, whatever you do to the bottom, you have to do to the top, or you change the value of the fraction. So we're going to multiply both the top and the bottom by the common, by 2. And so the top is going to, the numerator will be 40. The denominator will be 6. 46 minus 19/6 equals x. And we get x equals 40 minus 9, 21/6. I'm going to now simplify that. So, oops, I turned it all blue. Back to red. And now I'm going to simplify the fraction, give it in reduced form. So 6 and 21 can both be divided by 3. So that is going to become x equals 21 divided by 3 is 7. 6 divided by 3 is 2. Put a box around it, and now we're going to check it. We got to plug it in to check. So is it true that 20/3 equals 7/2 plus 19/6? Now again, I'm going to need a common denominator to be able to add 7/2 plus 19/6. And so I'm going to use a different color here. And remember, I'm checking, I'm asking, is this equal? So my common denominator again here is going to be 6. To get 7/2 to have the denominator of 6, I'm going to have to multiply the top and the bottom by 3. So the top will become 21, bottom will become 6. And then we're going to be able to add that to 19/6. And we're asking, is that equal to 20/3? So I'm running out of space here. I'm going to rewrite it. Is it true that 20/3 equals 21 plus 19 is 46? That is true, because 46, if we divide both the top and the bottom by 2, would equal 20/3. So I'm confident I have the right answer. Okay, this next one here, we have mixed numbers. So we're going to make a note to ourselves up here. We're going to say when you have mixed numbers and we're working with them in algebra with equations, we're going to convert mixed numbers to improper fractions. Okay, so let's go ahead and do that. So this side is good. It's already an improper fraction. 2.5. That is 2 times 2 plus 1 is 5. So the numerator will be 5. Denominator stays 2. This one, 2 times 6 plus 1 is 12, 13, 6. Okay. Okay, now k is our variable. We want to leave that by itself on one side of the equation. So we're going to subtract 5 halves from both sides of the equation. I'm going to then rewrite this here. 11/6 minus 5 halves. This 5 halves canceled on that side. And then this is what is left on this side, 13/6k. Okay, now to simplify this side, negative 11/6 minus 5 halves, I need a common denominator. So I'm going to change colors. And oh gosh, 6 again. Didn't give much variety here in my common denominator. So this will have to be multiplied by 3 on the top and the bottom. That will give us 15/6. And now that will have a like denominator with negative 11/6 equals negative 13/6k. All right, now we're going to subtract these fractions here. Remember, when we add or subtract fractions, the denominator stays the same, and we just add or subtract the numerators. So negative 11 minus 15 is negative 26 equals negative 13/6k. Now, are getting close. We're almost there. Change colors one more time. And right now the k is multiplied times negative 13/6. We want just 1k. And a helpful technique when the variable is multiplied by a fraction and you want it to just be 1 is to actually multiply that variable by the reciprocal of the fraction. And we'll see why that's so helpful in a minute. So we're going to multiply this by 6 by negative 6 over 13. So it has the same, reciprocals have the same sign as each other, but the numerator and the denominator are reversed. And so, of course, we got to do the same thing to this side. So what happens here is we can what's called cross cancel. And perhaps you've done this before in a math class. When you have one, so now we have to think, what is negative 13/6 times negative 6/13? When two numbers are diagonal from each other in a fraction, they actually cancel out to 1, because you can do 6 divided by 6 here, and this other 6 divided by 6, they both equal 1. And these 13s will also cancel out to 1. And so then what we're doing is just 1 times 1 on the top, or negative 1 times negative 1 on the top, which is 1, 1 times 1 on the bottom, which is 1. So this side just equals k. Yay, that's what we wanted. Now this side, we have another fortuitous canceling here. These 6's will cancel. And then here we have 13 and negative 26. They have a common factor. They can both be divided by 13. So 13 divided by itself is 1. 26 divided by 13 is 2. So basically it's simplifying before you do the multiplying. So the 6's cancel to 1. Now we're going to multiply across the top. Negative 1 times 2 is, times negative 2 rather, is 2. And on the bottom is just 1 times 1 is 1. And so that is just 2 divided by 1 is 2, so that is k equals 2. And I ran out of space to plug in my answer and check. I did plug it in on another piece of paper earlier, and it did work. So I'm going to let us move on. K equals 2. Okay, last one. This equation does not have fractions, but as we will see, the answer is a fraction. So sometimes you have an equation with no fractions, but the answer is a fraction. So let's try that. I'm going to add 7 to both sides. And I encourage you to pause the video and try this yourself. Do it yourself. 4x equals 22. Divide both sides by 4. X equals 22/4, which can be simplified. They can both be divided by 2. So x equals 11/2. And lucky us, we do have room to plug in and check. Is it true that 4 times 11/2 minus 7 equals 15. We have a little question mark. Is that true? Well, when we multiply a whole number times a fraction, we put the whole number over 1. We're going to, rules for multiplying fractions, multiply across the top, across the bottom. I can do my cross-canceling here first. 2 divided by itself is 1. 4 divided by 2 is 2. So the top is 22. The bottom is 1, so it's just 22 minus 7. Is it true that 22 minus 7 equals 15? Yes, it is true. So we have solved correctly. Okay, fantastic. Let's try proportion equations. So, proportion equations is when one fraction equals another with the variable that you're solving for in it. So that's the case here. We have a fraction equals another fraction. So we're going to do the example of just solving it like we've solved all of our other equations using inverse operations. So on this side, x is being divided by 15. The inverse of that is to multiply by 15. So we're going to multiply both sides by 15. Since we're working with fractions, I'm going to make 15 into a fraction by putting it over 1. This side, the 15s cancel and become 1, so that's what I wanted. I just get x on that side. On this side, I have a choice. I can just multiply across the top. 15 times 2 is, that looks like a ratio here, let me erase that. 15 times 2 is 30, and the bottom equals 3, and that simplifies to x equals 10. I could have alternatively done my little cross-canceling and seen that 3 and 15 have a common factor. They can both be divided by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. And then I just get to do 5 times 2 on the top, which is 10. 1 times 1 on the bottom, which is 1. And that would get us right to 10 here. So either way is fine. You don't have to use the cross-canceling technique, but it is nice because you often get to multiply smaller numbers. We're going to plug in our answer and check. Is it true that 2/3 is equal to 10/15? And yes, that is true, because 10/15, if you simplify it, both 10 and 15 are divisible by 5, is equal to 2/3. Yes, that is our answer. Okay. So now for this one, we're going to divide this space in half. We're going to show you how to do it 2 different ways. First, we're going to do it the traditional way. Right now, the x is on the bottom of the fraction. So we have to get it out of the denominator. So we're going to actually multiply both sides by x here. That will cancel the x here. X divided by x is 1, and leave us with 5 on this side. And then this side will be 35. I just made it x over 1. 35 times x divided by 2. And then I can multiply. I'm trying to get the x by itself, so I'm going to first get rid of that 2. I'm going to multiply both sides by 2. In this case, 2 over 1. The 2's will cancel. This side becomes 10, and I get 35x on this side. And then my last step will be to divide both sides by 35. So I get x equals 10 divided by 35, which I could simplify. Let's see, 10, they're both divisible by 5. 10 divided by 5 is 2. 35 divided by 5 is 7. So x equals 2/7. Now I'm going to do the cross-multiplying method. So let's write that up here. Cross-multiply. Not the same as cross-canceling, which we did here. We can label that here, cross-canceling. Cross-multiplying is different. Cross-multiplying is a technique where, let's do this in a different color. Do it in blue. So let's rewrite our proportion here. A fraction equals a fraction. When you have a fraction equaling another fraction, you can do this cross-multiplying technique. And you may have seen this before. I made that all messy now. Let's make that x what we can do with cross multiplying, it's a shortcut where if you multiply the numerator and denominator of one fraction 5 times 2, it equals the numerator and the denominator multiplied together, the product of those, on the other side, x times 35. I think I'm going to write that as, okay, x times 35, or 35x. Notice that, so this side would be 10 equals 35x. Notice that this is the same as what we had here. So it gets us to that step kind of quickly. Now we got to get the x by itself, so we're going to divide both sides by 35. And that's the same thing we have here. That simplifies to 2/7. So the cross-multiplying technique is very helpful. It can be used with decimals as well. So I can say 15 times 14.7, or I could do my multiplying with parentheses, either way, equals 1.06 times x. And then I can evaluate 15 times 14.07 is 220.5 equals 1.06x. Divide both sides by 1.06. And we get x equals 208.02 if I round to the nearest hundredth. All right. So, I forgot to draw my other one there. Cross multiplying. All right. How about this problem right here? We cannot cross multiply yet. In order to do cross multiplying, you can only have a fraction like a over b equals c over d. You can only have one fraction equals another. And then I can rewrite that as the equation a times d equals c times b. So I'm not there yet because I have this other term, this 4 added. So we're going to need to move that over to the other side first. So we're going to subtract 4 from both sides. And that's going to get us 13 equals 40 over 2x. Now it's not quite a fraction equals a fraction yet, but we can easily make it that by putting the 13 over 1. Putting any number over 1 makes it a fraction without changing the value. Now I can use my cross multiplying. I can say that 13 times 2x is equal to 40 times 1, which is 40. 13 times 2x is 26. X equals 40. Divide both sides by 26. And we get x equals, what do we get? 20 over 13. Okay. I'm going to have you try these last two on your own. I'm going to put the answer here. To get credit, you have to show your work and show how you got this answer. There's the answer to this one, 0.021. And the answer to this one, 1.12. Okay, so you're going to do your work and get those answers. Remember that you can put whole numbers, you can put them over 1 in order to use this cross multiplying technique. Okay, and that is it.